So this is 5-4, indirect algebraic proofs. And there are proofs in the name, but they're basically different, and I think they make a little bit more sense. So the proofs we've done so far are direct proofs, or like the regular proofs you guys love. This time we're doing indirect proofs, which require indirect reasoning, which is our first term. And I'm just going to re-underline it here, which is blotted out on your sheet. That assumes that the false, you conclude the false, and then show that the assumption led to a contradiction. So we're going to do indirect proofs, which is the next term, or proofs by contradiction, which you would temporarily assume that what you are trying to prove is false. And then you show that because this is logically impossible, you prove your assumption false and the original true. So these take 3 steps, and you can read the whole sentence, but essentially it boils down to these 3 steps. Step 1, identify the conclusion you're asked to prove. Step 2, use logical reasoning to show that this assumption leads to a contradiction. And step 3, point out that the assumption leads to a contradiction. Or the original conclusion, what you asked to prove. So that's a lot of stuff. We're going to go over it, but that's what it boils down to. So we're going to state the assumption necessary to start an indirect proof. I'm going to skip A. You're going to do that one. I'm going to do B because it's a little bit different. So if 6 is a factor of n, then 2 is a factor of n as well. So if 6 is a factor of n, we need to do the negation of that, basically. So you're going to write, if I'm going to type this out, I don't know why I'm trying to do that. I'm very smart. So if 6 is not a factor of n, then 2 is not a factor of n. So really you're just doing the opposite. It's just you put a not in there. So the other one, think about it. If it doesn't equal ABC, then, if ABC does not equal XYZ, what's the opposite of that? That's on you. I'm sure you did great. So we're going to go to indirect proofs. And I feel like having the whole thing up here will be a little bit easier. So let's go to that. So I'm going to do this one. Write an indirect proof to show that if negative 3x plus 4 is less than 16, then x is less than negative 4. You're given that negative 3x plus 4 is greater than 16, and x is less than negative 4. I want to go to this because I want you to have everything. So, same problem. You have to start off. The key thing is step 1. You write the negation. So the negation of x is less than negative 4 is x is greater than or equal to negative 4. Or more simply, if something is less than something, the opposite of that is either it is greater than or it's equal to. So you have to start off. If you have any problem like this, I would make a table. I meant to use the arrow. Ugh. So you make a table. If it's not less than, then it would be either equal to, which is negative 4, which is right here, or it would be greater than, which is negative 3, negative 2, negative 1, or 0. So you plug those in, you get 16, 13, 10, 7, and 4, respectively. So when x is greater than negative 4 and negative 3x plus 4 is less than 16, we have all this information. However, if you look at it, in both cases, none of these numbers are larger than or equal to 16. They all go down, 16, 13, 10, 7, and 4. So in this case, the assumption leads to a contradiction of the given information that negative 3x plus 4 is greater than 16. Therefore, the assumption x is greater than negative 4 must be false, so the original conclusion that x is less than 4, negative 4, must be true. This may be confusing, we're going to work on it, but you can do it, so you just do the opposite. Kind of confusing, but I believe you. Good luck.